Bismillahirrahmanirrahim. So today uh, we will discuss some more problems also. So the first problem is regarding the fundamentals of the probability theory. So we will see some mini problems. I think 12 problems, at least 12 to 13 problems we will see. So this first problem is regarding the fundamentals of the random process. You can see there is an experiment. The question, they consider the three random experiment. So first of all we will take the experiment 1. So in the experiment 1, you can see that a coin is tossed. So what is the sample space for this experiment? So that is the main thing. So the sample space for this experiment, what is the sample space for this experiment? Okay, so what is the sample space for this experiment 1? For the experiment 1, the sample space is let's say I will first write about the part A. For experiment 1, the sample space will be S, which is nothing but you are tossing a coin, so you can expect head and tail. Okay, that is the regarding experiment 1. And regarding experiment 2, what is the sample space? You are tossing a die, so you can dice, you know what is dice actually. It is a cubic object, and you can see that some points are marked here. One dot is marked here, for example. This is 2 dots, maybe here 3 dots, like this. So there are 6 faces for the dice. Okay, and and if you throw the dice, the probability of getting any of the face, everything is equally equiprobable, or we can say that you have an equal chance for getting any of the face. So what are the possible outcomes? You can get at least 1 dot, maybe 2 dot, maybe 3 or 4 or 5 or 6. So this is the sample space. And experiment 3, in experiment 3 you have the sample space. Okay, you are selecting a ball from an urn which is numbered from, that is, you have a urn and you have lot of balls here, 2 3 then 0, like this. You have lot of balls, 9 balls are 9 many balls are there, and each ball is numbered like 0 1 2 up to 9. So there are 10 balls actually. So you can have a sample space 0 1 2 3 4 5 6 7 8 and 9. So these are all the possible outcomes. Okay, this is one of the problem from the problem sheet. You can see the reference number 1.1. Okay, and what will be the relative frequency of the outcome in each experiment if you are repeating this experiment? That is, in experiment 1 you are repeating this experiment. For example, if you are repeating the experiment, maybe in the first trial, okay, this is the trial number, for example. I will just write the experiment 1. This is the trial number. So in the first trial, sometimes you may get tail or head. Okay, maybe tail again, some head again, head. Maybe in the third trial you may get head, then you may get tail. Like this it will continue. Okay, so if everything is, if you take a coin which is having head and a tail, and if you are tossing it, okay, if you are tossing it on the ground, for example, and if you repeat this experiment, you may almost, if you go to up to infinity, if you are repeating the trial infinite number of times, you may get equal number of heads and tails. Okay, so the relative frequency, that means the frequency of head, the number of heads will be equal to number of tails, and this is the case of an unbiased coin. Okay, unbiased coin. So unbiased coin means you are not making any trick on the coin or something. If you are not biasing the coin, that means the chance of getting head is same as that of chance of getting the tail. That is the situation for experiment 1. And experiment 2, regarding the experiment 2, similarly, you are tossing a die. Sometimes you may get 1, sometimes you may get 5, you may get 6, maybe get 4, maybe getting 3, like this as you increase the number of tiles. But the number of the frequency of 1 will be equal to the frequency of 2 will be equal to frequency of 3 will be equal to frequency of 4 will be equal to frequency of 5. Okay, like this almost everything will be equal if the number of trials tends to infinity. So this is the situation. Similarly, for experiment 3, you can explain like you will get the frequency of 0 will be equal to frequency of 1 will be equal to frequency of 2. So what do you mean by the frequency? That means the number of number of zeros, number of ones and number of twos in an experiment, if you are repeating this experiment many times, okay, or if the number of experiments tends to infinity. So everything will be almost equal, same number of times for each ball. Okay, it's ball, I think so, right? Yes, for each ball. So the probability is almost the same. Okay, so this is the first problem. Next we will move on to the second problem. So question number 2. You can see that a die is tossed. So you know that we have a die here, and for the die you have 6 faces. Let's say this is 2, 3, the 2 faces, like means 6 faces are there. So you are tossing a die. Now the question is, you are tossing a die and the number of dots facing up, that means here you see when this is the facing up, so the number is 1 here. Suppose sometimes it may face like this also, the number the facing up, here it is 3, okay, like this. So it is counted. So die is tossed 2 times. Okay, so you are tossing 2 times. Okay, you are tossing 2 times. So what will be the sample space? That is the main thing. So the sample space, the first part is the sample space. We will talk about the sample space. Okay, so you have the trial 1 and you have the trial 2. So you can expect something like this. For the trial 1 you can get 1, 2, 3, 4, 5 or 6. In the trial 2 also sometimes you may get 1, 2, 3, 4, 5, 6. Okay, so like this you may get something like, it can be 1, 1, it can be 1, 2, it can be 1, 3, it can be 1, 4, it can be 1, 5, it can be 1, 6. That means in the first trial you may get 1 and in the second trial you may get 1. In the first trial you may get 1 and in the second trial you may get 2. Like this up to 6. Similarly, in the trial 1 you may get 2 and trial 2 you may get 1. In the trial 1 you may get 2 and you may get 2 in the trial 2 also. So like this 2, 3, 2, 4, 2, 5 and 2, 6. So these are all the possible outcomes. Next you can see something like, if in the first trial if it is 3, you may get in the second trial sometimes you may get 1, sometimes you may get 2, 3, 4, 5 or 6. Sometimes you may get in the first trial 1, first trial 4 and second trial 1. 4, 1, 4, 2, 4, 3, 4, 4, 4 5 and 4 6. So these are all the possible outcomes. Next 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. And in the second and in the first trial you may get 6, second trial you may get 1 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. That means you have a sample space with all these elements, and what are number of possible outcomes are 36 outcomes you can expect, okay, in these experiments. So what is so this is the sample space, and the second part of the question you can see, find the set A corresponding to the event. Number of dots in the first toss is not less than the number of dots in the second toss. Suppose N1 is the number of dots in the first trial and N2 is the number of dots in the second trial, then our condition is that N1 should be greater than or equal to N2. That's it, okay. Then what it will be, you take here, for example, if you take 1 comma 1, this is okay, because in the first toss you are getting 1 and the second toss is also 1. But if you take 1 comma 2, you see in the first toss you are getting 1, but in the second toss it is greater than, right? So you see here, okay, sorry, I have made a mistake here. You see here, please read the question, question part B. That means the number of dots in the first toss is not less than. That means the number of dots in the first toss should not be less than, actually it should not be less than. Okay, it's correct. So it is not less than means N1 should be greater than N2. So you can see if I take the outcome 1 comma 2, it is not satisfying because 1 is less than 2. So I can take a lot of outcomes according to this condition. I will show it in a color. You can see here, this is N1 should be greater than N2. So I can take this outcome 1 comma 1 is okay, 2 comma 2 is okay, and 2 comma 1 is okay because 2 is greater than. So you have a lot of outcomes like this. That's what I am marking here, okay. And 4 comma 4, 5 comma 5, 6 comma 6, you have a lot of outcomes, okay. So you can see the lower part of this, if you consider this as a rectangle, you can see it's lower triangle. You can see this part of this whole thing will give you N1 greater than N2. So that's regarding the part B of the question. Now we have part C. So we will see what is part C. So the part C, find the set B corresponding to the event. The number of dots in the first toss is 6. So the number of dots in the first toss is 6. Okay, you see here the number of dots in the first toss is 6. So what are those events? That means the first toss is having the number of dots as 6. So the outcomes are the first toss should be 6. So 6 1 you can expect 6 2, 6 3. That means first toss is 6, maybe second toss maybe 4 also. First toss is 6, second toss maybe 5 and 6. Okay, so this is, and next one, the part D of the question, does A implies B or B implies A? That is the main question. Does A imply B or does B imply A? That means if you get A, whether you will automatically get B. You can see here, this is my outcome B. You can see in the question it is given B is the set of outcomes with this criteria. So part C is our B and part A and this part B is our A. This is the set A. So set A corresponds to all these outcomes which I am showing in the red color, you can see. So that is A. Okay, that is A, part A. So if I get part A, then I cannot confirm or not whether it is part B. If I am getting part A, you can see part A is having lot of elements, which is the lower triangular part of this matrix. You can say this is my part A, and my part B is something like, my part B is only this row, right? That means 6 1, like this, up to 6 6. So does part A implies B or B implies A? If I get B, then I can say that I get A. That means B is the subset of A. That's why. But A is not the subset of B. So B is the subset of A. So we can say that B implies A. That means if I get B, then it will be from set A also. Okay, it will be coming from set A. It is coming from set A. It is also belonging to set A. That is the meaning. Okay, next we will see A intersection B complement. That is the part E of the question. A intersection B complement. You know that what is A? Our A is something like the matrix here. And what is my B? My B is something like here. That means 6 1 up to 6 6. So B complement is nothing but except this row. That means I will not take the last row. I will not take the last row. That will be my B complement. Then we will see what is common in this both. So what will be common in this both? That means the intersection. Intersection means common in both. Okay, common in both. So what it will be common in both? Something which is common in both, that is A intersection B complement is nothing but you have this matrix. Okay, this is your matrix. That's it. Okay, last row will be absent and these guys will be absent. So A intersection B complement will be this much. That means you may get the set, you may get a lot of things. Okay, like 1 1 you may get here. Actually you may get something like this, 1 comma 1. Okay, then 2 comma 1 and 2 comma 2, then 3 comma 1, 3 comma 2 and 3 comma 3. Then you may get 4 comma 1, 4 comma 2, 4 comma 3 and 4 comma 4, right? Then you may get 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4 and 5 comma 5. So this will be the intersection. Okay, and you have part F. Part F. What is part F? Part F is nothing but, you see here, let's see, it is a matrix, it is a set C to the event. The number of dots in the dice differs by 2. Okay, so what will be the dots which is differ by 2? You can say like this. In the first trial, for example, in the first trial, trial 1, you may get, example, in the trial 1 you may get like 1, and in the trial 2 you may get 3, like this. Okay, or you can have in the trial 1 you may get 3, and in the trial 2 you can get 5. So like this you have to fill this table. Okay, that is your C. After that, find A intersection C, and you know what is A. A is this set. Okay, we have already seen. So this can be easily obtained. If you have any doubt, you can discuss with me through the blackboard. Now we will see another problem. We have two dice. We have two dice tossed. Okay, we have two dice. That is, you have the dice 1 like this. You have a dice 1, and you have another dice. Okay, and both are tossed. Okay, both are tossed, and the magnitude of the difference. Okay, the magnitude of the difference, that means you have the dice 1 and dice 2. So maybe the dice 1 will give you the outcome n1, and dice 2 will give you n2, and you will calculate n1 minus n2. That means the magnitude. For example, in the first trial, suppose in the first trial you get that means in the first trial, suppose you get, in the trial 1 you are getting suppose 3, and the trial 2 you are getting 5, then you will take magnitude of 3 minus 5, that is nothing but 2. So this is what you are going to do. So then what will be the sample space? That is the question. So suppose you may get the same numbers, then the magnitude will be 0, right? If you are getting same numbers for both of the dice, when you throw, then it will be 0. Sometimes you may get the difference. For example, you are getting 1 and 2, or 2 or 1, then you will get the difference 1. You may also get the difference 2. You may also get the difference 3. You may also get the difference 4. You may also get the difference 5. How you will get difference 5? Because when you throw, suppose you get 6 for the first dice and 1 for the second dice, then 6 minus 1 will be 1. Or else you can get 1 and 6. That means 1 minus 6 magnitude is also 5. So that is the sample space. Then we have the second part. Okay, find the set corresponding to the event. The magnitude of the difference is 3. So there is only one set for this, because only you may get the magnitude of the difference is 3. So what is that? Is set A, we are saying. So set A is nothing but the magnitude of the difference is 3. It's only one element in that set. So what is the probability of A? That's also can be calculated. Probability of A is nothing but the number of elements, it's 1. And what is the number of elements in the sample space? There are 6 elements. So it's also 1 by 6. Okay, I hope it is clear to you. Next we will see another problem. A binary communication system transmits a signal X that is either +2 or -2. Okay, so there is a communication system with a transmitter. Your transmitter will either give +2, or sometimes it will give a pulse of -2. Okay, that is the idea. So it will give either a +2 or -2, and this output we will always call it as X. Okay, so X can take two values, either +2 or -2. Okay, so a malicious channel, the signal is transmitted by the transmitter. Now it is going through a wireless channel or any channel. Okay, a channel, you know, the signal, for example, if you are talking about the wireless communication, the channel is the free space, you can say. Okay, so it is going through a channel, can be a wire or can be a free space or anything. Okay, that is not mentioned actually. So it is going through a malicious channel, and you are getting the output. This is your receiver, and the receiver is getting an output y. This is transmitting x, and the receiver is getting the output y. Now, the magnitude of the received signal is having a characteristics. That means this guy, this y is having a characteristics. What is that? The received signal, a malicious channel will reduce the magnitude of the received signal by the number of heads it counts in 2 tosses of a coin. That means if you are tossing a coin 2 times, then the sample space you may get, if you toss a coin 2 times, you may get tail in the first tossing and you may get tail in the second tossing. You may get tail in the first tossing and you may get head in the second tossing. You may get head in the first tossing and you may get tail in the second tossing, or you may get head in the both case. Okay, so you see here, you can see here the received signal is decreased by an amplitude which is equal to the number of heads it counts in 2 tosses of a coin. The number of heads you may get, it is here 1 head, for example. Here also you may get 1 head, or you may get 2 head. Okay, that means you may get at least 1 head or 2 head, or sometimes no head, 0 head. Okay, that means only tail if you toss a coin. So what I am going to say is that your magnitude may change by a number 0, or magnitude may change by a number 1, or the magnitude may change by a number 1. It's already there. The magnitude may change by a number 2 also. So these are all the possibilities. So we will find what is the sample space. So I am going to represent x like this and y here, and I transmit +2. If I transmit +2, then sometimes I am getting this case, that means there is 0 head case, that means no change. Then the y may be also +2. Am I correct? So you may get here also +2. So you may get transmit signal is 2 and received signal is 2. No problem. Sometimes you may get like this 1 head. That means you transmit 2 and the magnitude is reduced by a factor of 1. That means you may get 1. That means you transmit 2 and you may get 1. Sometimes you may get a case of 2 heads. See here, this one. That means you transmit 2 and the magnitude is decreased by 2 itself. That means you may get 0. That means you transmit 2 and the magnitude has gone to 0. Okay. Okay, this is the case. Now we will see what will be the situation if I transmit -2. So the magnitude of this is -2. If I transmit -2, if there is no change at all, that means 0 head case, that means that the magnitude is not at all decreased, then I will get -2. I will get here -2. Okay, and correspondingly here there will nothing will be there. Now if I transmit -2 and if I get a condition of 1 head situation, that means my magnitude will get decreased by a factor of 1, not factor, it is decreased by a number 1, then what I can expect? I can expect only -1 because the magnitude is reduced. Then that means this is the situation. So I can represent like this. So I transmit -2 and I am getting -2. No issue. -2. I transmit -2 and I am getting -1. No issue. Okay. And I transmit -2, and if I am getting a case with 0 head situation, that means not 0 head. If I am getting a case with 2 head situation, that means my magnitude will reduced by a number 2. So I may get 0 also. So these are all the possible outcomes. Okay. And here nothing is there. So what are the number of elements? How many elements are there in the sample space? There are 6 elements in sample space. Okay. So what are those elements? It is shown here. This is the first element, second element, third element, 4, 5 and 6. There are 6 elements in the sample space. Now it has been asked in the second part of the question, it has been asked that find the set of outcomes corresponding to the event the transmitted symbol was definitely 2, plus 2. So you are going to transmit plus 2 and you may get sometimes 1. For example, I will draw here. Your sample space is given like this, x and y plus 2, and this is 2, 1, 0, okay, minus 1, minus 2, so 2, 2, 2, 1, 2, 0. So in this case, this is okay, and you transmit minus 2, so minus 2, sorry, this is minus 1 and minus 2, okay, nothing is here. So you transmit minus 2, you transmit minus 2 and you may get sometimes minus 2, and you transmit minus 2 and you may get minus 1, you transmit minus 2 and you may get 0. So you can see here in the first situation, you are transmitting, the question is given like you are transmitting, find the set, the transmitted signal was definitely plus 2. So you can get an output, that is you are transmitting, you don't know what is, but you are having a situation like, for example, 2 and 1. If you are receiving 1, for example, if y equal to 1 or y equal to 2, you can say that it is greater than 0. So you can say that x was 2. But if y equal to 0 you received as 0, then there are 2 cases. You can see here, y equal to 0, this is your y, actually this is y, this is also y. So y equal to 0 means it can be, your x can be plus 2 or minus 2. So this situation we cannot take into consideration because we cannot say what was the originally transmitted signal. So if y equal to 1 or 2, definitely x equal to 2, okay, that's it, or else x equal to, we cannot say. If y equal to 0, we cannot say, can be x can be plus 2 or minus 2, because there are 2 cases you can see like this, okay. This is what I am saying here. So this situation has to be avoided. So you can see here, we can get the 2 condition for the y, that is one is y equal to 1 or y equal to 2. So these are all the 2 condition, okay. That's it, that is the answer. And next is describe in words the events corresponding to y equal to 0. So y equal to 0, when do we get y equal to 0? Y equal to 0 you may get if x equal to plus 2 or x equal to minus 2, you have a chance that y equal to 0, okay. And at this time, during this time, actually it is difficult to find x, because x can be plus 2 or minus 2. So we cannot say anything about x during this time. Next is another problem. A die is tossed and the number of dots facing up is noted. Find the probability that find the probability that the elementary events under the assumption that all the faces of the dice are equally likely to be facing up after a toss. Okay, so the first part of the question, actually, what is the probability that all the faces of the dice are equally likely? So if you are repeating this experiment many times, you may get all the faces equal number of times. If you note out the frequency of occurrence of each face, then you can see that it will be almost equal. That means by the sample space you may get 1, 2 or 3 or 4, 5 or 6 if you toss a die, and you know that if you toss the dice, always you may get any of the outcome. So the probability of getting any of this outcome is 1. It's certain. That is, the probability of any sample space will be 1. So we can say that this probability of sample space is equal to 1. That is nothing but the probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. Okay, and it is given that all are equally likely. That means all are equal probabilities. So if all are equal probabilities, then the probability of 1 will be equal to probability of 2 will be equal to, there are 6 cases actually, 6 cases. So probability of 3 will be equal to probability of 4 will be equal to probability of 5, which is equal to probability of 6. And you know that the sum of this is 1, so each one should have 1 by 6, right? That is the probability. And you can see that all the events are mutually exclusive. This is very, very important terminology. Mutually exclusive. What does it mean? Mutually exclusive means if you get 1, you will not get 2 or any other number. That means if you are getting a particular number, other number could not occur. Okay, and similarly, like in tossing a coin, if you get the head, then you cannot get the tail at the same instant. Okay, you may get either head or tail. That means if you get one event, the other event will be automatically blocked, you can say. That is the mutually exclusiveness. Okay, next, what is the probability that the second part of the question? Now we will move to the second part of the question. Find the probability that A equal to more than 3 dots. So the event A, what is the probability of A? So we will see what is the sample space. You have already know the sample space. And what will be the set A? More than 3 dots means what? It can be 4, 5 or 6. And what is the probability of A? How many elements are there? You have 3 elements. Okay. Then what is the how many elements are there in the sample space? The sample space is having 6 elements, so the probability is 1 over 2. Okay. Then what will be regarding the B? How many odd number of dots? You can see this is B is the odd number of dots. So what are the odd numbers? Odd numbers can be 1, 3, 5. So 3 elements are there. So probability of B is 3 divided by how many elements are there in the sample space? There are 6 elements. So it is 1 over 2 again. Okay. So that's the part B. Now find the probability of A union B. Okay. We'll find the probability of A union B, A intersection B and A complement. We will see what it is. Okay. And this is part C, and A is equal to, you have the set A is greater than 3 means 4, 5, 6. And B is the set with odd numbers 1, 3 and 5. And your sample space, I will write it 1, 2, 3, 4, 5, 6. Okay, this is my sample space. So what is probability of A? Sorry, we want to calculate something from the question, that is A union B. What is A union B? A union B is a set already 4, 5, 6, then 1, 3, 5. Okay, 4, 5, 6 and 1, 3, 5. You can see the 5 is repeated 2 times, so we will write only 1 time anyway. So how many elements are there? There are 1, 2, 3, 4, 5. Okay, so 5 elements are there. And how many elements are there in the sample space? There are 6 elements. So it is the probability of A union B is 5 over 6. And what is the probability of, next is we want to find A intersection B next. So what is A intersection B? What is common in this? Something which is common in this, it is 5, I think so. Okay, so it is nothing but the set 5. So how many elements are there? 1 element. So probability of A intersection B is nothing but 1 divided by number of elements in the sample space is 6. So it is 1 over 6. Next, it is asked the A complement. And what is the A complement? A complement is the set which is not in A, and you know the sample space is 1, 2, 3, 4, 5, 6, and your A is just 4, 5 and 6. So 4, 5 and 6 here, and something which is not here in A is nothing but your 1, 2, 3. 1, 2, 3. Okay, A complement which is not here in A. So 1, 2, 3. So there are 3 elements. So probability of A complement will be 3 by 6. It is 1 over 2. Okay, that's it. So this is the problem. Now we will see another problem. A random experiment has a sample space S is equal to, sample space is given A, B, C and D, and you can also assume that all are mutually exclusive. That means if one event happen, the other will not happen. Okay, and it is given that probability of C comma D, okay, is equal to 3 by 8. So we can write like this: probability of C comma D is nothing but probability of C plus probability of D, and everything is mutually exclusive, and there is nothing common in that. So probability of C comma D is probability of C plus probability of D, that is given as 3 over 8, and probability of B comma C is also given, it is 6 by 8. So you know that it is nothing but probability of B plus probability of C. Okay, and probability of D is given, it is 1 over 8, and probability of C comma D, probability of C comma D, probability of C comma D is nothing but 3 by 8, which is nothing but probability of C plus, sorry, it is already given, this is not required. Okay, that's it. So using the axioms of probability, the question is, using the axioms of probability, find the elementary events. So using axiom of probability, that is, you know that the probability of sample space will be 1. And what will be the probability of sample space? It is nothing but the probability of A. You know this is the sample space. Sample space. It is nothing but the probability of A plus probability of B plus probability of C plus probability of D is equal to 1, right? And you have 2 equations, and another equation you have probability of C plus probability of D is 3 over 8, and probability of B plus probability of C is equal to 6 by 8. So you can solve, there are many equations, 3 equations. And the probability of D is also given, it is 1 over 8. So there are 4 equations, this is 3 and this is 4. There are 4 equations and there are 4 unknowns. You can easily calculate. So you solve this and you will get probability of A is 1 over 8, probability of B is 4 over 8, probability of C you will get 2 over 8, probability of D you will get 1 over 8. So this is how to solve this problem. You can solve these equations and get all the probability. Okay, so by solving, how to solve this, that can be easily done. Okay, I will not write here. Okay, sorry. So solve the equations, solve equations 1, 2, 3 and 4 and obtain, you will get the probability of A, I will write it 1 by 8, probability of B, it's 4 by 8, probability of C is 2 over 8 and probability of D is 1 over 8. And if you can check it to check your answer, probability of A plus probability of B plus probability of C plus probability of D, you will get it as 1 over 8 plus 4 by 8 plus 2 by 8 plus 1 by 8, which is nothing but 8 by 8, which is equal to 1. It's nothing but the probability of the sample space. Okay, that's what you are getting. So this is how you can solve this problem. Okay, and another problem you can see by using the notion of set theory, you have to prove this, and this is a homework for you. Okay, so this is very important problem. You can check it. Okay, next another thing, a coin is tossed 4 times. Define the sample space corresponding to the experiments. So if you are tossing a coin 4 times, you want to find the sample space first. Okay, the answer, the sample space, if you toss the coin 4 times, for example, you may get all head. In all tosses, sometimes you may get head. You may get 3 head and 1 tail. You may get also get 2 head, okay, then a tail, then head, right? So head, tail, head, okay, head, tail also you may get, then head, tail, head, okay, then you may get head, tail, you may get head, tail, head. So these are all the possible outcomes. Now that's first part is over. Also give the subsets corresponding to, the next part is also give the subsets corresponding to the following events and find the respective probabilities. That means, so this is the first, find the sample space. This is the first part, find sample space. And the second part of the question, okay, I will write it. A be the event in which more heads than the number of A, B the events with more heads than tail. Okay, so I can write like this, this events, number of heads is more than the tails. So you can see the first one, yes, that's fine, because head, all are head. So this is an event, head, and head, T. Okay, then I can also write head, tail, head. This 3 heads and 1 tail, and head, tail, head. Okay, then tail, head. So these are the number of events of heads which is more than the tail. So 4 cases are there. So here the sample space is having 16 and this guy is having actually 4. So what is the probability of A? Probability of A is 4 over 16. You can calculate, it is 1 by 4. Okay, so that's it. So this is the probability of A. So how to calculate actually, next we will see we will see an event, the third part of the question. Let B be an event in which tail occur in the second and fourth tosses. That means your tail will be occurring in the second and the fourth tosses. That means my sample space I can write like this. First trial can be head, but second trial should be tail. That's what I am saying. Then head, and this can be tail. Okay. Then I can have another case, head, tail, tail, tail. Okay. How to choose all these things? You have to see the sample space and you have to select the proper event. So you can also have tail, tail, head, tail. Okay. You can also have all tail. So there are 4 cases. Okay. So there are 4 cases. Okay. There are 4 cases. Did I make any mistake in the previous situation? Oh, I have made a mistake here. This is not 4 actually. This is 5. So this is 5 means it should be 5 over 16. Okay. Next is, you can see here I have 4 cases and I have 16 total cases in the sample space or outcomes in the sample space. So the probability of B is 4 over 16. So this is how you can calculate. Okay. I hope it is clear to you. I am winding up here. Inshallah, we will discuss the remaining things in the next class. Thank you.